Hello, everyone. It's about time to start. It's my pleasure to welcome you all at the next talk that me and my colleagues from Skype company has prepared for you. This talk is about testing. But actually, it's not about testing principles or approaches in general, but it's specifically about testing environment. I will ask you first, who of you tests in production? Yeah, I see some strong men in the public. Or who of you tests on your laptop and then it looks everything all right, you push the code into production. Well, it happens. It even happens for us. We have production access for some not important projects or very internal things. But I hope that for everything that your user will experience, that you do proper testing in your designed environment. Unless you are our competitor. Shortly about myself, my name is Radoslav. I've been working last over 5 years in Skype. I am a software developer in the Skype database platform team. I'm mostly dealing with tooling. I'm not a DBA on a daily basis, but I develop tools for either DBAs or other development teams who work with platform. Skype database platform offers platform as a service. So there are about 25 other teams which daily contribute to the platform. And we make their life easier with tools like automated deployment. Maybe you have, I hope that some of you went to Alexei's presentation. He is my colleague from Skype and he's also here. He has talked about architecture. So I will also mention a few terms from that terminology, like Railman, which is release manager automation, PL proxy, PGQ, long distance replication, and things like that. Let's move forward. Shortly about history of Skype environments of databases. Before February last year, 2016, so a year from now, a year ago, we had production environment. It hasn't changed, we still have it. There is a bunch of databases with one specific database called ConfDB. It is a central place to hold configurations. Those configurations include which databases do we have, on which hosts, on which host names, which database objects we have on every database, what are the statistics of those, what are the roles and what are the other teams and which team owns what. So those are very necessary information so we can do automated deployment. To know what to deploy and where to deploy, and if the deployment is eligible for that. Overall in production we have close to 1,000 active hosts and over 2,000 active databases. Many of those are sharded. So one logical database can have even hundreds of physical shards. And another aspect of environment is a scripter host. It's a special designed host for external scripts. External scripts mean that it's in most cases Python script which just connects to database and does some ETL. We can generalize it's data maintainers or PGQ consumers which then send data or communicate with other channels. So that was a production environment. In a test environment, we had multiple instances, but there is one central point. We call it int, or it's based off word integration. This is the environment that every release has to go through when they want to be released to production. And the architecture is the same, just the scale is much lower. There were two hosts. One was for newer version of Postgres. One was for the older, until all the older ones get migrated. 385 databases because we didn't need that many shards as they are in production, and one scripter host, which was enough. Overall, the environment was huge. You can imagine that many databases, that many development teams producing and testing it on a daily basis. So we didn't want, for example, performance testing performed on that environment. We created a new one for performance testing or development and so on. They were clones of the int environment. However, those clones were done quite slowly. It took 3, in worst case, even 4 hours to clone because the environment int was approximately 1 terabyte big. We were on some storage, we did snapshots of file system, but still copying over a 1 terabyte of files, it took time. So it was time consuming. But overall, there were many problems associated with these environments. I'm sure you haven't seen such picture yet today. It's Mr. Creosote. Mr. Creosote is a super extraordinary big man, and one day he comes to a restaurant and he orders everything, like everything in the restaurant, and he eats it, manages to eat it almost everything as well. Just in very end, he orders one small piece of cake, he eats this piece of cake, and what happens? Well, he explodes, like literally. There is a link to the video for those who have strong stomachs. And this picture represents what our environment was like, the int. It was huge, massive, robust, under very high load, and every small small changes could make it unavailable or malfunction, or any small mistakes. So what were the problems? Firstly, there was no connection, direct connection between production and int. What means that we had to make sure that by policies and various checks that whatever gets released has to go first to int and then to production. There were also cases, for example, you need to roll back from int because it's still a testing environment. You create a new release item, you redeploy, but maybe there is something forgotten, which has a little bit made some difference. Or quickly there is some problems and the DBA fixes it manually, or even the engineers. So this kind of differences occurred and they accumulated years over years. Also, with this, we introduced different kind of policies, like developers cannot access in the environment directly. So different policies. Tracking systems, they checked that who accesses it and so on. There was even a new position in Skype created, like database policy manager, who was like sending reports and so on to get rid of the issues we had. Pure hygiene. You mentioned 25 development teams, everyone testing, creating, they use automated tests mostly, creating the users with every automated test, doing orders, calls, whatever they wanted. And sometimes they forgot to remove the data. Even they were instructed to do so. Another policy was that every data had to be registered to be removed in the end. Not always has been followed thoroughly. Lack of ownership. Over the history of Skype, new teams were being created, split, they were projected, was split, created, change of owners. There was not real ownership, not 100% everything was correctly tracked. And even if there were problems and we found an owner, they may not have time to fix it immediately. Over years and years, the problems have been accumulating and the environment grew. As I mentioned already, it was about 1 terabyte in the end. And it wasn't even a problem that it was so big, but the problem was that it was never endlessly growing. Every couple of months, the DBAs would have to increase the capacity, adding new CPU and memory and disk and so on. And the clones were slow. When I remember issues that integration environment had problems, it was very slow, unresponsive. development testings, the development teams were stopped, and the DBAs had to work a couple of days to make it working again. Okay, come back. So we wanted to fix those, and we even had a very few successful attempts. For example, we created a tool called DB Spider. It was a special tool who would recognize all data and would remove it. Also, we created a tool for tracking the differences. We would compare the database in production, and we would compare databases in test, and if if there were differences, we report it. However, you can imagine there were like thousands. So it was not possible to quickly fix those. And most of them were maybe not actual. Like the code was almost the same. The human sees that there is not the actual difference, but by the pure source code definition, there were different. Or there were some roles had different privileges in other environments. Files were different. But nobody really had time to fix those. So by once. So how it worked, that development team, which at one point I also worked for in Skype myself, we had to check first if what we are changing is the same in production, so that we can test it in int as well. However, those were good attempts, but didn't exactly work in the end. The picture looked the same still. I mentioned the diffs. We created a nice tool. We called it database diffing tool, simply DDT. I prepared this slide especially for you because we want to open source it. It's very nicely written pure code tool, at least I think so, that does comparison of databases. So for example, at the bottom line in the yellow, you see that you just specify you want to diff source connection string, target Postgres connection string, and it would give you exact output. What differs? In this example, we see that PG schema entitlement is origin 1. It means it only exists on source. And then we have some different diff element, schema reputation. There is 0 attributes different, which is okay, but it has a child. It has a child called child function get. So function is reputation.get, and it has a different source text. Here you see, like the source text was pretty big, but you can imagine like long source text here was different on target and on source. And we had a nice web page which would track those. So what does it do in the background? First, it dumps. The diff is nothing more just dump and diff. But the dump is also very interesting. It's on the top. It's something like a PG dump, so but not yet exactly. What is the most different perspective is that PG dump would output you the SQL text, and this is very difficult to parse, like to grab and substitute and lots of set around. Very difficult. So we created this new tool DDT would dump in a way that it would create objects, a hierarchy of tree of objects. So in the top level you had PG cluster, which has children databases and roles, for instance, and settings. A database would have children schemas, and so every object has attributes, which is like owner or source code or whatever is typical for the object, and children. A table would have children columns and so on. And for example, index or triggers. The triggers would have attributes, a definition. So in this case, we can very easily compare. The comparison, the diff is straightforward. You just take those two dumps, you find an object of the same name and same time on the other side, and compare the attributes. And it would reply to you immediately that attribute source text is different. And recursively call on children. This tool for our test environment is now deprecated. We don't use it anymore, but it still applies for production environment because we have failover done by the logical replication. So we still use it, and we want to open source. And even this DDT dumping, we will reuse in rebuilding the test environment, as I will talk about soon. I believe that it can help you also to the community, because often you really need to work with databases. Like you need some data or some structures for whatever, many different tasks, and you can use just the dump. And in Python, when you then work with the dump, it's super easy to just find the node that you are looking for and read the attributes. A programmatic approach. So we have the agreement of the management that we will release it. So Microsoft is now the good guy. It supports open sourcing. So what were the principles of the new environment that we wanted? There were quite a few. First, no differences, by definition. And no differences mean structures, queues, consumers, replications, database external scripts. For example, in the old test environment, we didn't have failover or disaster recovery site. The requirement was we will have it. Same naming. For instance, in old test times, we had everything had test in the end. Like database would have test, the trigger would have test, like services would have test. The reason why was that DBAs, who have access to both test and prod, they wouldn't make a human error and they wouldn't deploy to a different environment. So that was the reason. But we decided to get rid of it, as now 90% of deployments are automated anyway. The topology would remain the same, just the scale, of course, we will lower down. If a database is in production sharded for 256, we will just create 2 shards, 2 or 4 in test. And what about data? Yeah, if we recreate databases from scratch, based on production dumps, what about data? Well, it's difficult, because first of all, security. We cannot take a look into production data. Only DBAs can. And second, there were so many, so much. So we wouldn't have any. We would have to find some rules how to define what should be copied and how to obfuscate the data. Again, like some different InfoSec approvals, how data can be obfuscated. So decided no production data, only those data which development teams will generate by the tests. However, some data we still need in test. Some metadata, some configurations, some statistics. So yes, we will do some few exceptions, but we will be restoring the data from test from int environment in a loop. So after we rebuild a new, we will restore few tables defined by users, but not everything, just minimal. And the databases should be very small. We had the ambition that all new environment will be like few gigabytes big. We didn't manage in the end, but still, we have it very much smaller, many times smaller than it used to be. And fast cloning. So if you are a development team and you need environment for yourself that nobody would access, you can ask and we will easily clone the environment for you, fast. And we will resync the test environments regularly. Big advantage. If there is any problem or data grows, doesn't matter, we will resync. No DB Spider. The DB Spider is the tool for removal data. It's not needed anymore because with the resync, everything gets wiped out anyway. And policies. Stop to different policies. So now the database policy manager role doesn't exist anymore. And developers have access to all the environments, including the integration one. Full access to database as super users if they want. They can switch to super user. They can go to the host, set up anything, scripts, everything. So we DBAs are not scared anymore that they would break anything. Even if they do, we just resync. How does it work now? From the first glance, the picture looks similar to the previous one, but there is a significant difference. There is an arrow, strelka, as I heard from yesterday's excursion. There is rebuild. We will call this operation rebuild. From production, we will pick one environment in test and make it like a production one. And then for all the other environments, we will be cloning. In fact, build environment and all other and int and pre and deploy and performance testing environment are all the same. They are equal. We just decided not to be rebuilding straight production to int or production to dev because there is a risk if something fails, and sometimes does. So we pick one environment which nobody uses. It's our internal one. We rebuild it, and if everything is okay, we store the build into repository and clone from that. So this picture is a little bit simplified. The clone doesn't happen from build environment directly, but there is, after build environment is created successfully, we store into repository and build from there. So in the end, it's a matter of configuration, what to rebuild and what to clone. And we can clone anything to anything, so it's very easy now. And all the process has 3 steps. Dump the production and few necessary data from test. For the test, we chose in the environment. Rebuild, and everything is okay. Clone. Most environments we clone daily. But for example, development environment or integration environment, we clone just weekly so that teams have some time frame when they can integrate with each other, like test their APIs work together well. So overall, the most important part is rebuild. Clone is still just, in the end, a copy of files, which is fast now. But I will talk about different, now I will talk about different components of rebuild, of the big chunks of work that had to be done. So dumping first. So for the production, we need to dump pretty much everything. First of all are the database structures. We used pgdump, and also during the rebuild we just use pgrestore of those. This is the important part. We dump only those shards which are, not all, only those which we will restore, usually just first 2. First 2 means 0 and 1. And also we have a disaster recovery site. Disaster recovery side, we access we have a consensus that we access those by DNS. So the DNS, named like database name dot datacenter1.db points to a master, and database name dot datacenter2.db points to a failover one. But those can be switched Anyway, we will dump both of them. By the way, it's not a secret. We have data centers in Luxembourg and Dublin. So in real life, instead of DC1 and DC2, there is lux and dup strings. And DDT dumps, another thing that we use very much. We reuse from the diffing project of unsuccessful test environments because some configurations are not are present as data inside databases. Configurations, how the replication should work, how the PGQ is configured, how the rows, which attributes they have, and so on. It's defined as data, the configuration as data inside databases. So it's not a structure anymore. We use database DDT dumps for that. And so easily for restoring, we just we open the JSON and use the parameters of those. And what else we dump is the database scripts on scripter hosts. In production, we have 9 scripter hosts. And you know how it is when you want to remove something, you usually don't remove, just you rename or move to other location. So the DBAs had done it in the past. So we decided not to copy anything, any legacy, anything which should be killed. We copy only those which have been active for last week. So new test environment is clean and fresh. Nothing old remains. And what we need to dump from test or int? A couple of data. I mentioned the confdb. Most of the tables from confdb we need to restore. Those are owners and database definitions, and locations, IP addresses, and necessary configuration that we need for deployments. And some classificators. For example, if you have an order, you buy a product in Skype, typical classificator says like which are the possible orders or what is the order workflow. So from ordered, you can status you can get like confirmed or denied, and this kind of classifications we need to restore. And passwords. Of course, we cannot restore roles with their production passwords. So how we do it is with the production DDT dumps, we dump the rows with their attributes, and from integration environment, we just dump the password. And when we restore, we combine those two. We will create rows with attributes from production, but int passwords. An interesting case is also for external DB scripts, because some of them connect to external systems, like wherever they need. For example, today lots of scripts connect to Microsoft account services, because now we have like tight integration between those two. So integration scripts need to use integration keys, files, destination URLs. So those things. Going forward, we have for restoring data, we have a tool called DataMass. It's a pretty complex tool in the end. However, the idea is simple. We just define those tables which need to be restored. Those we restore in confdb. Those definitions of which tables we store in confdb, those are over 400. Altogether takes 7 gigabytes of pure insert SQL statements. Most of them are just several kilobytes, but there is like 5 big guys which take a lot. The biggest one is the different configurations of products. So for every country, for every country you have different configurations of how many minutes you can order and which they, how much they cost and all the discounts. There's like millions of different products combination. That's also needed for in-test. Dumping of those take about 10 minutes. Restoring takes about 50 minutes for your curiosity. But in the end, DataMass does simple things. It dumps the data with pgdump, with specified tables, and when restoring, it uses just PSQL and replace the SQL insert commands. Just interesting thing is that the DataMass itself is DataMass. So the configuration of DataMass is also added in one of the tables. It's like recursive. Replications. Alexei, just an hour before me, has it's in the back. He has explained a lot how it works. So I will not go into details. I'll just mention that we use LonList3. It is replication-based, logical, based on triggers. So on a master table, you have a trigger which catches the events, inserts, updates, deletes, and truncates. And over a worker or some system process, it replaces the same SQL statements into a target server table. What has to be, which tables have to be replicated? It's defined in the production real databases. So we have to use, in this case, we use DDT dumps. And from internal tables, we find out. So what are the PGQ cascades? PGQ cascade is roughly PGQ cascade name is roughly a queue name, and every node has defined a node type and provider and which consumer works for that node. And of course, which tables have to be added into replication. And so we parse easily those DDT dumps. We take a look which nodes exist on which databases, which tables have to be added, and we generate 6,000 commands. It used to be 12,000, but we group them. For example, we can, if those of you who use LonList3, if you add table into replication, you can add several of them at the same time if they don't have handlers. If they have handlers, you have to do it one by one. And in Skype, lots of tables have handlers, about half. I was thinking whether to include this code, how to set it up, but in the end I did, because if you don't use it yet, it is a simple example, half a table is replicated. First, you just generate ini file, then you create a node. A node can be root, branch, or leaf. So in this case, it's root, based on connection string and node name. You start a worker, which is the process which transfers those insert, updates, and deletes events, and you add table. This LonList replication is used both for making the data available from one database to another, completely unrelated one, or also for failover. For failover, historically, we've been using the logical replication LonList3. On the top, you also have the example how we make the data DNS names. So if we have sites primary and secondary, those have DNS names. Those have DNS names in test environment generated with a hash with a dash collocation 1 or DC1, and second one has DC2 dot environment name. And when you are a developer, you are not very much interested in which of those two is active master at the moment. You just use the DNS database name.int. It really simplifies the life. Database name.environment, and you get there. The DNS will take care which one is master at that moment. And the scripts. This is little more difficult case because we need to combine things from production and test both. So from production we take all executables, all config files, but only structures. In general, values of the config files we need to take from int. And cron tabs we take also from production. From int we take values, because in the values there can be int specific or test specific destination URLs, files, keys, settings. Also we take PGPass. Of course, passwords specific has to be same as it used to be. And other files, which are certificates, key files, other configuration files. But to make sure, because in the old times there was mess. Lots of files were not used anymore. Like, you wouldn't know immediately which one is actively used and which one isn't if you log into the system. So we decided that all the files which we will copy over have to be referenced from within the ini files. So, but it didn't affect much of the development teams because they used to have this practice before that anyway. One thing for these database scripts, we use a SkyTools library, which was open sourced and developed in Skype some time ago. And it really makes the scripting easy. It gives a framework that most of your code is your actual code. The initialization and logging and parsing the config files and creating database connections, everything is already included. So your code is only the needed one. And we have interesting problem again. So imagine that we rebuild a database from scratch from production. So what it means? It means that all your development changes has been wiped out. So you don't want that if you are a developer. So we have thought for a while and then decided, let's do it in this way. When Railman, which is a release manager automation, releases anything to int, it will mark it down on a specific database. We call it release history DB. And when we rebuild, we take a look what has been released to int and not yet to production, and we replay. And it works well. For statistics, so one release, it's database release. It can be changing the database structures, like tables, creating or changing database functions, setting up scripts, replications, whatever. One item takes about 1 minute of deployment, and in general, we deploy to Skype production maybe 200 per month. Here we have decided, should we deploy all of them? And decided not. Only those which have been not younger than 2 weeks. Why? So we get rid of those stale ones who will never maybe reach production. So this is something for developers to have in mind. When they develop, they need to know that if they have to either release to production in 2 weeks, or they have to reinitiate int deployment again. So that was the rebuild. Big chunks of work we have covered. And quickly summary. We read it through. quickly summary. First, we take a look if fresh dump is available. If it is, we reset Postgres. Reset means we purge the Postgres. We uninstall the package, also all the configurations, everything, and also all the system roles with it. We restore databases, which means databases, external, like other libraries, like long list PGQ. We create roles, pre-create PGQs. And one comment. We have used fsync off parameter on the Postgres configuration. You know what it means. It means that the database would commit transaction before making sure that it has been synced to file system permanent storage. It's very dangerous. Should never be used. But in this case, we used it before because we use only build environment, which nobody uses except us. And even if something fails, we fail everything and start from scratch. And this fsync off parameter made restoring of database structures, you imagine 350 databases, from about 1 hour to 3 minutes, fast. So a tip for you if you will play around only on your laptops. We pre-generate database DNS. It's also for developers and for database scripts to easily connect to databases. They don't need to know host names, only database name. That's it. We set up long list replications. One thing. We change the primary DNS names because long list replication sometimes in production those are switched. The previous failover is now master. We have to be switching it again in test, so it matches the same, based on what long list 3 replicas have done. We restore data with data mass. Do some ConfDB configurations. Not go some necessary configurations for RPCs. We run discovery. Discovery is this special agent on every database host, which would connect to database host, take a look which objects exist, and store it into central configuration database, ConfDB, which is then used for making trends, statistics, everything what is needed is in ConfDB. So for example, if you are a developer and you need, it's a side note. If you're a developer and you want to know what is in production and you don't have production access, you just look into ConfDB via specific web interface or desktop application. We have both. And you know which objects exist, on which databases hosts, what are the definitions, how much they are used, and so on. And quickly to finish, we set up external scripts, configure PG bouncers, replay those items which have been deployed before into int, but not yet to production. And if success, we copy to build repository. For your summary, for your curiosity, it almost always succeeds. So maybe once a week or so it doesn't. I will then explain why. And clone. If a build has been done and is fresh, the clone process, which is programmed and scripted in Ansible, it takes a look into repository and clones. Clone is simply stop everything, reset database home, like purge PostgreSQL, all the system roles. One remark. Before, we used to, as you know, most of us, and in test environment, all of our hosts are virtual. So before we clone, we used to just dismiss the hosts and create from scratch a new virtual host. But this part was not stable. Sometimes it took a long time and didn't finish well. So to overcome, we keep the hosts as they are. We just remove everything what is Postgres related and system roles related, and it's much faster now. So we stop, install a new installation of Postgres, a clone, copy the files from the build repository, generate database names for that environment. Database names for that environment has the suffix in environment name. Set it up some necessary configurations for RPCs, discovery, and start, and it works. Altogether, about 20 minutes of time when the environment is not available for usage. Issues. It's by definition. We synchronize based on production. So if production has issues, again, all test environments will have issues. But we don't find it as a big problem because if that's the case, DBAs work hard to fix those first in production. So with next clone, it gets better. Why sometimes the rebuild fails? Because we cannot dump everything. Imagine we have those 350 databases which we restore. Not all of them are available because sometimes there is work in production. Sometimes, by the way, and a host is down, not responsive. We cannot dump it. So in the past, we did it in the way that we would store a host dump into repository, and we would just use the latest one. But if you ever do something similar, don't do it, because what it means that some databases would be fresh, like from yesterday, and some would be like from 3 days ago, and you would give it to developers. So it's an incompatible state. So we decided all or nothing. That means that sometimes the rebuild fails. Maybe once a week or so it happens. Most of the days of the week it works. And we rebuild daily. And interesting problem with Railman replay and data mass. So what happened? Chicken and egg. Imagine you are a developer. You update a database structure, a table. You add a new column, a very easy operation. And the table is data masked. So in the rebuild process, first we restore the structures, which is the old one, and we want to data mask with the new one. It fails. Yeah. The data is new one from int, and structure is old from prod. Fails. No. But at the same time, Railman replay has to be the second one because it uses data from confdb for deployments. So how we did it? First, with the data mass, it works for let's say almost all the tables except exceptions. Then we replay, and then we data mask again. And in second attempt, all tables has to be data masked. Otherwise, it would fail. And this has been working well. Didn't have any more issues with that one. Another thing, the Railman replay works just for 2 weeks. So if you're developing, you have to have this in mind. Yeah, and the principle fail on everything. We call this new approach small revolution. So it happened after 10 years of iterative changes in databases, and now we made it completely new. What is necessary for both DBAs and devs is to know if they're working with environment, when it was rebuilt or when it was cloned. Actually, clone is not that important, but the rebuild, the snapshot. And we have used like modern approach. We made a bot. So a bot would, here's an example. There is, I would read it. QA status, QA is like test status, int environment, and variables. And it would give you when was the last successful clone, what was, and the build information. And the build information, when it happened, the start time, like 11th of March. And also Railman replay items, which have been replayed. So this is important for developers to know. It also gives us proactive messages to chats for DBAs. So we know if something fails, We don't have to go to logs and find it out very, very difficult way. We are informed immediately in the Skype chat. Very convenient for us because we use Skype chat as our work tool. So the bot would report immediately if something fails, a clone failed or rebuild failed, and we can act very easily on that. And I would suggest to take a look, because Microsoft has released a framework how to create bots. It's for Skype and also for other very common channels like Facebook Messenger, Telegram, Office 365, SMS, Kik, and so on. The link is there. Very easy. The framework has libraries for C# and Node.js. And especially in Node.js, you can create your Hello World bot in a couple of minutes. You just copy-paste the Hello World code, and you can have your bot, which would respond just anything to your message, like hello or привет. Like really fast, minimal code. And the last slide from me, the summary. We are very, very happy about that change. Many things have improved. Altogether, dumping time is about 30 minutes, and it is done on the background. Rebuild is altogether 3 hours. 3 hours is still quite time, but it's done without any human interaction and on the background. Most of the time is spent on the data massing and Riemann replay. About more than half of this. Clone time is about 20 minutes, out of which 5 minutes is just wait for DNS to synchronize. However, the biggest advantage is the hardware fell requirements from 1 terabyte for environment to 100 gigabytes for fresh build, and it grows up to 300 gigabytes when it's under usage. So new test data created, which are not removed. And so when it grows, we remove it. Clone time, it used to be hours, now it's 20 minutes. And we can easily add a new environment. If you want new environment, and you reach us 30 minutes with configurations. Efforts of DBAs significantly dropped. In the past, I remember, was 1 DBA dedicated to test environments. Now there is no one, and if something is wrong, we usually just reinitiate clone. Also, tools like DB Spider, which would do cleanup or trackings of diffs, deprecated. For developers, also easier life because they have full access now, no restrictions. And last but not least, the production is like production. The test environments are like production. So what you test is actual and it's real. In the past, we used to have incidents. Maybe Skype, sometimes Skype had incidents. maybe once in the second month or so, it was caused by testing not respective to production. Now we got rid of it. And that's all from me. I will gladly answer your questions. So, yes?
You are not using any cloning of the Hyper-V level?
The question is if we cloned by Hyper-V level. No. The clone is now very fast. It just copies the files, or maybe altogether 5 minutes or so. Most of these 20 minutes which are taken, which is taken by clone is reset Postgres. And then there's 5 minutes to set up and things like that. So there was no need for that. It's 20 minutes and done at night.
Hello, thank you for. You told us about test envs, but what about load envs? How do you set up them?
like load environment,
Yes.
like stress, like performance testing.
Yes, yes.
The same. It's we just clone the environment, and those environments, all environments built in test, they are equal to each other. How they differ is like by the suffix name and by the consensus for what we use them.
Okay, and hardware in test and production are the same configuration?
Yeah, yeah. You mean like you mean the testing, load testing, like in production?
Yeah.
Mm-hmm. No, well, no, we don't have this.
Okay, not the same amount of data, of course. It's unreasonable. It's unreasonable to take the full clone of your production, but could you just test one shard, for example, and something like this in Word? Or you're not doing this?
In that case, for such big projects, and when we expect problems or we anticipate big usage, what we do is that the developers cooperate with DBAs. So the DBAs would set up something from in production environment, and together they would work on that.
Okay, thank
you. It happened in the past several times.
One more question. How would you handle if there are some necessary to do data changes? So, because I think on the subset you can't test fully the impact of an EML, which will be part of a patch.
So the question is about what do we do about data changes? What kind of data change? What data you mean?
Time to time you want to manipulate the database structures, do some aggregates and so on. But how you can be sure it will be fine if you do not have any instance of a full copy of the production?
No, actually, I don't completely understand the question. Well, we never had full copy of production, and we cannot have by definition. Well, the developers have to themselves pre-generate data if they need. Well, most of the configurations are the same. Like if it's a metadata and classificators, they are the same in production and test environments. Just the user data is not the same.
Thank you for the talk. And my question is to continue previous speaker. Can you explain how your development team chooses what data actual from prod can you transfer to int?
The question is no data. The answer is no data we transfer.
This is a fake data, of course.
No. So we had this dilemma at the beginning that which data we will choose and obfuscate, like change the usernames and so on. We decided not. So all the data in test are from test. So how we do it is that when we rebuild, during the dump, I can go back. This is dumping. From production, there is no data dumping, only from int, which we restore in a loop. So we dump data from int, which was the one chosen environment from all the test environments. We store the dumps as SQL insert files. We rebuild structures, replications, everything, and we data mass or restore the data.
So you make fake users, fake data, and so on?
Yes.
And you make it from original data?
Sorry?
And you make them from original data?
No. For example, there is a Skype client which connects to test Skype client, which connects to test database, and that can generate data. That can create user, and most of the data just comes from automation. So there is a Skype identity team has APIs how to create users. So all other teams, when they need something, they call their API. The users got created, and they can work with their workflow.
I'm Alexei from Skype. Actually, I would like to clarify. Basically, no data is copied from production. No user data. All user data for tests is generated during the tests, and from int we copy only some kind of metadata classifiers. But user data mostly it is just generated during the tests.
I will just make a summary note in the end. What I would like you to think whether this approach is applicable for you before it's late, before you have incidents and all this bad hygiene in the test. Second, the tool, DDT, Database Diffing Tool, we will open source, so please keep an eye on that and think if you can reuse it in your teams. Second, the bots. The bots can be done for this Facebook, Telegram, Skype, and other O365 mailing and so on. This is another aspect. And last, feel free to reach us. We will be here today, tomorrow as well. Me or Alexei, who just spoke. We will be glad to answer and to speak in person. Кстати, я тоже говорю по-русски. Я сам словак, учился в гимназии где-то давно по-русски, но наши языки такие похожие, что я, в принципе, все понимаю. Только что я более привык на английском в последнем разговаривать. Значит, можете на меня тоже на русский, по-русскому.